And welcome to another exciting and perhaps enlightening edition of our daily space weather here at the Smash News Network, least busted name in news. And congratulations on realizing the channel exists, and welcome to space. Exciting stuff going on as always. A major coronal mass ejection is propagating down in the southwestern limb. We'll get to it. We'll show you some more spectacular imagery here first. This is the last 24 hours in SDO 304 plus 193 angstroms. And let's take a look at the western limb here of El Sol. And that is the location from which that coronal mass ejection is propagating. We don't anticipate this one being earthly directed. In fact, we don't really see too much as far as earthly directed coronal mass ejections. There are certainly alarmist channels on YouTube that are getting people very frightened and very riled up about a heapin' helpin' of, well, frankly, just aesthetically pleasing activity, not anything that's particularly dangerous. Here's just the South Polar region. And the largest group of sunspots is this group right here. We'll show you some more spectacular close-ups of that when we talk about things like solar flares. Also a crown prominence down there in the southeastern polar region. Here is the eastern equatorial zone. We have had a significant reduction in solar filaments and a bit of an increase in solar activity here overall since yesterday. And thanks for leaving comments, Mr. Bordages. And there is the North Polar region. Couple huge filaments up there, like this one right here. You can clearly see suspended, and that one there. Some great detail there as a result of these composite wavelengths. So good. So good. And let's take a look at the past, well, this is yesterday plus today. SDO intensity gram. So we've seen growth of this sunspot. This one in the north. And this one mostly stable. This group here certainly harboring some complex magnetic fields. Let's take a look at the colorized magnetogram. That is yesterday, April 27th, plus today, April 28th. We did see a little uptick in the radio flux. We'll get to that here in a moment. First, let's see what's erupting as far as volcanoes go. And Nishino-shima there, outgassing some water vapor and other dense gas. That's from the 14th of April. I don't know why it's so old anyway. Let's check out the list here and see what else is erupting. So Nishino-shima producing about a 6,000 foot plume of volcanic ash, flight level 060 there over Nishino-shima. The Ryukyu Islands featuring Subanose-jima exploding, flight level 070. Popocatépetl exploding in central Mexico, 22,000 foot ash plume, flight level 220. NR Summit activity only. I don't know what that means. At Fuego in Guatemala, it appears to be erupting. Revenador in Ecuador exploding, flight level 160. It's a 16,000 foot ash plume in Sabancaya in Peru, producing a 23,000 foot ash plume. As it explodes, it's a flight level 230. Next, looking at global seismicity, there is the 90-day bar graph. There were some quite large quakes, the largest of which was at nearly 600 kilometers depth. There you go, 598.5 kilometers estimated depth at a 6.6 magnitude quake there near the Fiji Islands. It did feature some 4.5 magnitude, quite a bit of quakes there around the Pacific Rim. And thanks for leaving a comment, Robert. Good morning to you as well. Here's a 5.2 at Nepal. That one occurred at 1945 Universal Time. 1945, quarter of 8 Universal Time. That's quarter of 8 p.m. 1945 Universal Time, a 5.2 struck Nepal. South Sandwich Islands had a 5.6. That was at 1:07 this morning on April 28th. And then here's a great example of a foreshock taking place. Oh, it's only dag. That is only 7 seconds before the 6.6. 3:13 and 44 seconds, 3:13 and 51 seconds. So a slightly different depth there though. So that's interesting. A lot of people seem to think that deep earthquakes are indicators that there will be a larger quake at the surface. We've never cited that as an actual occurrence on the channel. Doesn't seem to be any sort of statistical correlation with that. But foreshocks are certainly a thing. So here's a great example of a 6.0 followed by a slightly deeper 6.6 and then of course a series of aftershocks. Those are all at varying depths. See this 5.5 at a much shallower depth there, 569 kilometers, and then a 5.5 at 571 kilometers. I don't know where some people get these ideas about earthquake forecasting, but it's pretty ridiculous. And of course, there are channels who are going to say, we're expecting a large quake somewhere around here. Somewhere in this area, we're going to see a large quake in the next undisclosed period of time. There was also a 5.7 in Indonesia. Directly north of Australia there, that was at 9:19 this morning. And let's get back to space. Here are the past 24 hours in the house favorite 171 angstroms wavelength. So we've also got, we've added 131 angstroms to help highlight active regions. The SDO providing its spectacular imagery as usual. So we're going to cover all kinds of other stats here. And before we do that, take a moment to visit the links below the video. If you've never checked out the merch shop, check it out. You can find a link to the Redbubble shop down there. You can save 20% site-wide for the Mother's Day sale there. Today's featured product is Google defined. Because if you're using Google as a verb, well, you're making my ears bleed, but we feel sorry for you, especially if you're also using it as a search engine. If you're using it as a verb, we just implore you to please use it correctly, because to Google something means to obtain biased search results on the World Wide Web by using the Google search engine to obtain those results. Let's use it in a sentence, shall we? I Googled it, and now I know less about it. Let us know in the comments what you think about the world's largest search engine. And what about the world's second largest search engine? Did you know that's YouTube, also controlled by Google? Yeah. Let us know what you think, especially about the past 3 years of, shall we say, interesting bias on the internet. And of course, you may be complaining about censorship and so on. We don't blame you if you are. Junkware. It's not just junkware anymore. As of 2020, it's officially deathware. The 10.7 centimeter radio flux has gone up slightly here to 141 solar flux units. That radio signal is emitted from the upper chromosphere and lower corona, discovered in 1947 by some Canadian radio astronomers. It's the most proportional data set that we have to sunspot number, as you can see here. Sunspot number here rapidly rising here now, making it up to 136 for the sunspot number, and the radio flux now at 141. That is a one-year graph from Solon.info. The red line is a sunspot number, the black line is a radio flux. And NOAA here forecasting, well, it looks like that has largely passed. So NOAA has forecasted some geomagnetic storm conditions here. We didn't really see those arrive. Just a little bit of geomagnetic unrest as we saw a KP4, but we have seen the highest solar wind speed we've seen for quite a while. And, we just tweeted about it, so make sure you follow us over on Twitter if you haven't. all over the internet at Smash-O-Mash. Yeah, Smash-O-Mash. Continuing on, here are the past 4 hours of Earth's magnetic moment from space. And it looks like some rather significant variations to the solar wind happening there, affecting the magnetohydrodynamic pressure. So this is the last 4 hours of Earth's magnetic moment from space. The space weather modeling framework in this imagery is depicting magnetohydrodynamic pressure, the units of which are nanopascals. We do have geomagnetically calm conditions, by the way. Next, ground magnetic perturbations, also for the past 4 hours. We show it daily on the channel, since people are very spooked and frightened because of nonsense propagated by ultra-rich YouTubers, convincing people that Earth's magnetic poles are going to reverse. Just a ridiculous idea. And there is probably more to back up Earth's poles snapping back toward the geographic poles than reversing. If they were reversing, you'd see all kinds of weird signals on this ground magnetic perturbations map, but guess what? You don't. KP index is a global geomagnetism average, and the current condition there is only 2.66. It's geomagnetically calm conditions. We never saw the geomagnetic storm that NOAA forecasted. Indeed, we didn't really see a CME impact either. We just saw coronal hole high-speed winds. Next, we'll look at the real-time solar wind, which, a quick reminder, is measured outside of Earth's magnetosphere out here at Lagrangian point 1. A lot of people seem to think that the real-time solar wind is like striking the Earth directly, but it can't be measured inside Earth's magnetosphere. That's why we have spacecraft out here orbiting Lagrangian point 1, because out there, the solar wind can be measured. And here's the data. So, now, this signal that you see right here, this is a switchover. That is the, what is that? That is the Discover switching to the ACE right there. But what's interesting about this is that we saw the solar wind make it all the way up to 730 plus kilometers per second. So that's the highest solar wind speed that we've seen in a long time. So it's a very strong, a very high-speed coronal hole high-speed stream. There's the 738, but also very diffuse plasma there at only 0.98 protons per cubic centimeter. The rest of that is fairly unremarkable. No major changes otherwise. Next, we'll look at magnetic data. There are your GOES magnetometers, and you see those very saw-toothed sort of signals there showing up on the GOES magnetometers. Those are typical of coronal hole high-speed streams. Continuing to see kind of lower highs and lower lows there on the GOES magnetometer. That's the GOES 16 and GOES 18, and next we'll look at the heliospheric current sheet. So I said there might be some delays of the North Pole current sheet showing up, and you can indeed see the sector boundary crossing there, moving a little bit to the east. So another forecast here. You can forecast this data by looking at sunspots, and you can forecast sunspots by looking at this data if you understand how the data correlates. That's our top view ecliptic plane field plot. Earth will still be in a South Pole current sheet, most likely, as of tomorrow's daily space weather video. There's the last frame. And just keep in mind the magnetic environment can change with basically no warning. So here's our line of sight field plot. You can see the solar B field in blue there, all fanned out, as we still aren't too far from the middle of the south heliospheric pole, really, the magnetic pole of the sun here. The southern one is sort of in the earthly direction at the moment. Next, coronal holes. And you can see a lot of South Pole-oriented coronal holes here, and also some North Pole-oriented coronal holes. And let's take out some views of those as well. This is 211 angstroms from SDO. And these are all South Pole, except for this little one down here. So that is the solar polar field reversal process playing out. as evidenced by the polarity of these coronal holes. It is the solar cycle process, the solar polar field reversal process, which is probably the process that actually drives the sunspot cycles. And let's get on to sunspots. So there's the current situation for sunspots. And I don't think we have any new sunspot groups here, so the sunspot number should stay rather stable today. We do have high likelihood of large flares in 3 different locations. So 3289, 3291, and especially 3288. 3288 is the most likely place to see a large solar flare actually at the moment, followed by 3289 and then by 3291. Let's take a look at some 24-hour videos of sunspots. There's a full disk view. Let's get a little bit closer there. Again, not a lot of changes happening in the past 24 hours, which is the time frame depicted in this video. Mostly stable there. Oh, it looks like one new group did form. So we've got one new group here at a rather high latitude. Right up there. So that should be a named group today. That'll be named 3293, most likely. And next we're going to go to energetic particles and solar flares. So no solar energetic particle events there. The ghost proton flux remaining flatlined, and the X-ray flux here coming up out of the B-class range as we forecasted yesterday. Although no more M-class intensifications, the largest flare of the past 24 was that was a C6.36 occurring at 1:10 universal time this morning. Let's take a look at our 131 plus 94 angstroms wavelengths. Here we've added 131 to the SDO continuum. There's 94 plus 131. Here's the full disk view. And we've got some close-ups here of both this group and this group. So there's that northeasterly group. And here's the largest sunspot group in the southern hemisphere. Just moving past the prime heliographic meridian there, just moving into the western hemisphere in the past 24 hours. And let's take a look at some more data here. We're going to step back as we're always wondering what's going on overhead. And a great way to figure that out is by using a star chart. We're using skyandtelescope.org's star chart at the moment. I like it. And if you're up before dawn, you may see Jupiter rising ahead of the sun. And after dusk, you may be seeing Venus, the third brightest object in the sky. Let's do a solar system forecast as Mercury is about to swing past. Here's where things will be in a week on May 5th. Looks like that will be full moon day. Actually the 6th. But there's where things will be on the 5th. And let's take a look at coronagraphs next. Here are yesterday's coronagraphs from George Mason University. We'll also show the Soho-Lascaux C2 and C3. Let's also show stereo A Here's a stereo A coronagraph. Keep in mind those images are not synced. It's the Soho Lasco C3 on the right and the stereo A Core 2 coronagraph on the left. And let's take a look at some custom videos here. Our fantastic composites featuring the SDO 193 angstroms wavelength along with the Soho Lasco C2 in red and C3 in blue. Now you can see some relativistic particles striking the aperture there. And that is, oftentimes that is coinciding with the coronal mass ejection. Let's move in a little bit closer here. And even closer, just to see if we see any plasma motions here associated with these CMEs. Not so much. I suspect they're largely from the far side. And here's just the 193 angstroms wavelength by itself. Again, I think the most likely place to see a large flare is at this point, this sunspot, as the plasma around it is looking a little bit unstable. So that will be a perfect moment to produce an earthly directed CME. We've got our fingers crossed on that. Let's hope we get some more aurora visible in Pennsylvania. And let's take a look at filaments next. So here's the filament situation. This is our L-Tide ground-based hydrogen alpha imagery. And the Remco Evenpool filament is still intact. A lot less filaments than we saw a week ago, but still significant filaments on the earthly facing portion. Quite a dense one here rising over the southeast, and you can see quite a few prominences all around the solar limb. By the way, if you want to name filaments after living people, just tell us which one you want named and follow the hashtag #NameThatFilament over on Twitter. If you don't have a Twitter account, why not create one? If you've unplugged from social media, frankly, we don't blame you, because it is really pathetic. Truly, truly pathetic. So here's this CME that we were talking about. It is in the process of unfolding as we stream the video. And that is pretty sweet. We could see more to come from that area there, as it looks like it hasn't completely exhausted its instability yet. There's still a whole bunch of plasma hanging out there. And also there could be a secondary event happening right here. It looks like some limb darkening down there. We'll have to keep an eye on that. And when I say ion, well, the pun is intentional. Here's the past 24 hours in SDO 171 plus 211 angstroms. And it's time to move to bonus features. Yes, bonus features. So the first will be the space weather, the satellites community dashboard here. Surface charging a little bit in the Central Pacific at the moment. A little bit of surface charging hazards there. Nothing major. Here's your GOES electron flux over the past 3 days. Those relativistic electrons are the free electrons at the F layer of the ionosphere, about 300 kilometers of altitude, as measured by radiography from the GOES 16 and GOES 18 satellites. Here is the forecast model. NOAA expecting a little bit of an uptick there in the electron flux. No arguments from me there. And here's a 1-year graph to put it in context, as we've just come out of the longest electron drought in the past year. The F layer of the ionosphere is where it's measured. We show the vibrational frequency on the channel daily. The F layer. Feel free to pause the video on this frame if you're not familiar with things like chemical concentrations, temperatures, and electromagnetic radiation penetration into the atmospheric layers. Here's just one slice. And we are seeing the ionosphere slowly calming down here following the strongest geomagnetic storm in over 2 decades. No, the aurora being visible in Arizona and Kentucky and Arkansas are not an indication that Earth's magnetic fields are going to flip or that they're super weak. A KP8 is a super strong geomagnetic storm. The CME was directed right toward the Earth, and it was at a high speed, and so it had a high impact. It doesn't mean the world's ending. It doesn't mean civilization is going to collapse as a result of it. And if you're frightening your viewers because they are ignoramuses, then you're also an ignoramus, as your viewers are not as dumb as you may think. We're also going to show the anomalygram. Here's anomaly in megahertz from a 30-day median. And you can indeed see a lot of red on there. But that should be slowly subsiding here in the coming days, as it has been subsiding for a few days. The ionosphere is puffing back down. And yes, good point, general disturbance. So lots of low-frequency anomalies happening there in the ionosphere, an indication that it has puffed up in response to incoming solar plasma. There is the latest image. That's 12 o'clock Universal Time, 12 noon Universal Time on the ionogram, and 12 noon Universal Time on the anomalygram. Low-frequency anomalies here, especially in the southern hemisphere. And let's take a look at the total electron content next. Feel free to pause the video on this frame if you're not familiar to distances to these type of things in miles. Here is our total electron content forecast. It'll show the free electrons between your GPS satellite and your handset. And things are quite orderly here. So no major anomalies happening here. And if your GPS is giving you problems, try using Wi-Fi location accuracy. That allows your Wi-Fi hotspots to help determine your location and help you navigate. Last but not least, we'll close out the space weather portion of the video as we bring you space weather and Earth weather together. There's the latest SDO intensitygram and latest SDO magnetogram. Again, we'll have one new named sunspot group right up here. That's likely to get a name. It's quite small. It's beta gamma class so far. And let's move to meteorology. Here are the jet streams of the central world. That's Africa, Europe, and the Middle East. And the jet streams would be probably the best signal if you wanted to forecast global weather patterns. There are the surface winds of this side of the planet. Let's head to the most populated portion of the planet. There's like 3 billion people right in that small area. These are the surface winds of the east. A strong low there, southeast of Kamchatka and southwest of the Aleutians. Here are the jet streams of this side of the planet. And we hope you're not being bamboozled by people who think that they know how to forecast the weather and seem to know nothing about physics. It's It's pretty pathetic. People are paid millions of dollars to straight up lie to you on YouTube. What do you think about that? These are the jet streams of the Western world. Quite a chaotic jet stream here over eastern North America. Some warm air being blown up into Greenland here. It's going to cause massive melting, and there's going to be massive melting in the U.S., which we will get to here momentarily. First, the surface winds. Shown how. And let's take a look at what's going on in terms of clouds and fog over this side of the planet as we zoom into the lower 48. The lower 48 states of AUSA, the allegedly United States of America, former nation, now banana republic, where there is zero accountability, rampant corruption, corporatism, and fraud. There are clouds and fog, depicted by 3.9 micrometer infrared radiation, by the way. And here's your weather.gov map. Weather.gov is where you want to go if your location is lit up. There are too many counties lit up there for us to go over, but we will take the liberty to show you the key. There is what those color-coded warning areas mean. And all that light green in the left side of your map means hydrologic output, which means massive melting as a result of record snowpack for a 7th consecutive winter. So here's your temperature anomaly forecast, since this is going to be the story. High temperatures, anomalously warm temperatures to close out April here. And indeed, that is going to cause some insane amounts of melting. Yes. Pay huge amounts of money for junk science and get junk answers. Yes. Have snappy answers to stupid questions, or better yet, stupid answers to stupid ideas. Or terrible models to back up terrible theories with utter garbage in, garbage out. That's the way computer programming works. Your computer didn't screw up. If your model is wrong, it's because you put garbage code in and you got garbage output. So it's going to be cold for the eastern half of the country and warm for the western half of the country. That's a 72-hour GFS temperature anomaly forecast in degrees Celsius. Next to your pressure and precipitation forecast, as it's about to get moist in the mid-Atlantic states, and some severe weather here, coming both to the Gulf Coast and to the East Coast. That's your 72-hour pressure and precipitation forecast based on the same model, the GFS. Let's take a look at pressure. So there's the pressure environment. We've got some low pressure there over northwest Texas, the North Atlantic, and the North Pacific. Windy.com, by the way, they got a great mobile app. Check it out. All kinds of features there. And next we'll look at lightning. We do indeed have some lightning in the Gulf at the moment, but things are pretty calm here, at least over the past couple of hours. And let's move to a real-time lightning map. Again, some thunder showers there in the Gulf. They are minor. Things have chilled since last night, where we definitely did indeed stream some severe weather on our 20-hour YouTube stream. And I like what you're saying, general disturbance. General disturbance. Here's some words of wisdom to share with people on the social media. Carbon dioxide is not a pollutant. Carbon dioxide is the base of every food chain on planet Earth. Anyway, here's your U.S. Doppler radar map. As it's about to start raining in Lehigh Valley, Pennsylvania. I put in my 32-mile solo ride yesterday. And make sure you follow us over on Instagram if you are not familiar with a crashing browser. Yeah, a crashing browser. Oh my gosh. All right. So at least we were able to show you the U.S. Doppler radar map. That was pretty sweet. And this is becoming the standard thing here as opposed to the exception. So anyway, I think we're going to close this thing out here. But we will do an extended stream once again today on YouTube, as it has been working out fairly well for us. So it hasn't been a huge pain. All right, you know what? I think we've got it back. We've got it back, folks. So just give me a minute to bring up the water vapor map and the shortwave radiation map, and we'll close out the video in the normal fashion. I'm telling you, it's that radar.weather.gov site. It's radar.weather.gov that's crashing the piece, that's crashing the browser. It's happened with multiple browsers here, so I don't suspect that it is the browser's fault. Here's your recap. Here's your initial cap. There is the clouds and fog scenario. And there is the water vapor scenario. You can see some dry, massive air here splitting, stabbing right into all this moisture, which is effectively a low pressure, and providing an impulse to not only move things, but it's also causing a barrier here, so that moisture is going to smash into that. There's going to be a huge pressure gradient there, and so on. Here's your recap. There is U.S. Doppler radar. Pardon the technical difficulties. There is the clouds and fog at 3.9 micrometer infrared radiation, and there is 6.19 micrometer radiation animation. It shows the water vapor. So thanks for tuning into the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. And by the way, welcome to the Neo-Renaissance. If you never visited our homepage, check it out. Smashomash.com is our homepage. In 2019, a crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped a maximum security social media stockade of the internet underground, Facebook, where we survive as producers of fortune. If you have a problem, nonsense on YouTube. And if no one else can help, and if you can find the videos, maybe you can hire the Smash Team. No, you can certainly hire them at smashomash.com/Smash Team. So help us out with clicks by visiting the channel, visiting the links, etc. Press like, subscribe, share, leave a comment, and stress less by picking up some Hemp Lucid products, perhaps. I mean, we've got expert analyses here, and I had a speed skater up, but this thing has moved around on its own. You can find links below the video to our Hemp Lucid affiliate shop, and you can save some dough by entering the promo code SMASHOMASH on checkout. And I'm trying to scroll here, but it's for some reason. There we go. Enter the promo code SMASHOMASH on checkout. Head to hemplucid.com or visit the links below this video or on our homepage. They are the most popular. And last but not least, if you want to support the channel via subscription services, consider becoming a member of the Smash Team. These videos were brought to you in part by the Smash Team, especially the Gold and Silver Smash Team members at smashomash.com/Smash Team. So hit us up on social media, join us on Discord, etc. Thanks to everybody who has supported the channel throughout the years. Another live stream coming to YouTube a little bit later today. Thanks to all the viewers who tune into the live premieres, etc. We'll see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.